guys, so for today's lesson, we're going to take another look at how we can represent statistics visually, another type of graph that we can use. The first one we learned about was box and whisker plots, and we're going to start off with that again today, a nice little review of what we learned and what we should know by now. So the first thing, hopefully we know that the mean is the average, which means it's this X bar here. If you're on the calculator and you see this X bar when you hit the stats button, that just means that is your mean, okay? The range in a data set, recall that is your highest value, so your max minus your min. The highest value minus the lowest value. Excuse me. Interquartile range. That is the IQR, which we said in the last lesson is Q3, quartile 3, minus quartile 1. Okay? And if you're looking at a box plot, it's very, I think it's easy to remember how to find the IQR if you're looking at the actual box. So here it says label the box and whisker plot and the skew. So the first point on the box and whisker plot, that is our minimum. And then we come to this first line here, part of the box, that is your Q1. And then we come to this part of the box, the middle, that is your median, or your Q2. Come to this part of the box, this is quartile 3. And then the last part of the box is your max. So for IQR, just remember that it is the first part of the box minus the last part of the box. So it's Q1 here and Q3 here. Okay, so Q3 minus Q1. That's where IQR comes into play. Okay. Then if you're taking a look at this box and whisker plot, try to remember skewness. It was the last slide in the last lesson that we did. Is this skewed left, skewed right, or no skewness at all? Well, this is skewed left because the tail on the left is longer. Right? This side of the tail is longer than this side of the tail. Right? So this one is definitely skewed left. Okay, make sure you guys get everything down that you need, and we'll go on to the next page. So for today, we're going to learn what the word correlation means. It's actually very straightforward. Try and think of what the word correlation means, just in outside of math. What does the word correlation mean? Well, it means that two things are related, right? If there is a correlation between, I don't know, a strong correlation, a weak correlation, it just means that those two things are related in some way. So if we are looking at the following examples here, I don't want to give you guys too much, but number one, the more time you spend running on a treadmill, the more calories you will burn. Think to yourself, are those two things related? If I run on a treadmill, for a long time, will I burn more calories than if I didn't run for a long time? And hopefully you would see that, yes, these two events are correlated. These two things are correlated. Yes, they are correlated. One causes the other. Okay, but then if we look at number two, taller people have larger shoe sizes, and shorter people have more organized lockers. Now think about that. Are both of these things correlated? Well, you could argue that taller people have larger shoe sizes. That could be correlated. But then if you look at the second statement, shorter people have more organized lockers. Is that definitive? Do we know for a fact that just because you're short, you have a more organized locker? The answer is no. They are not correlated. One does not cause the other in this case. Number three, the more apples on a tree, the more shampoo you will need. Are these two correlated? No, absolutely not. Apples on a tree have no indication, no effect on how much shampoo you need. And then number four, if a train increases speed, the length of the time to get to the destination decreases. Are those two things correlated? And yes, these are correlated. If we increase the speed of a train that we're on, it will take less time to get to the destination. Just like if you're in a car on the highway and you increase your speed from 65 miles per hour to 80 miles per hour, then it's going to take less time to get to your destination. Okay. Now, the whole reason we learn what correlation is because it's very important. It's a very important term when we look at our new type of plot, which is scatter plots. Okay? And in scatter plots, you have types of correlation. You have a strong correlation, okay? And that would be represented by these two figures here. Notice how all the dots are nice and compact, nice and squished together, kind of making a straight line. But then you also have a weak correlation, where again it's still dots, but they're not as close together as a strong correlation would be. Right? They're kind of more spread out. You can still kind of see a line, but they're not as correlated as these were. So here we have a high positive correlation. It's positive because as we go from left to right, we're going up. Here we have a high negative correlation. It's negative because left to right, we're going down. Here we have a low positive correlation. Again, positive because left to right, we're going up. But it's also low because the dots are not close together. They're spread out. So it's not a high correlation. And then lastly, we have a low negative correlation. From left to right, we're going down. Therefore, it's negative, and it's also low because the dots are not close together. Okay. So the stronger the correlation you have, let's choose pink. The stronger the correlation, the closer your R value is to 1. And the weaker the correlation, the closer it is to 0. So here's your easy correlation definition. The way we define correlation is by the letter R. Anytime you see the letter R, it means the correlation value. Okay, so here the R value, it's definitely a positive correlation. It's going left to right, it's going up, and it's in a straight perfect line. So the correlation value here is 1. It's the highest value you could have. On the other hand, this is negative correlation, but still in a perfect line. So this correlation value is -1. And then here, there is absolutely no way we know what this correlation is because there's no pattern to it. All the dots are scattered about, so there's no correlation here. That's a 0 correlation value. And then I really like this this website here, guessthecorrelation.com. If you go to that, you type it in, you hit new game. It's kind of like a Mario theme, and you can guess what the correlation value is. It gives you this nice little graph here. And as I look at this, you can tell that it's a positive correlation because from left to right it's going up. But it's not a very strong correlation because the dots are all scattered about. So you give it a guess. What do you think that correlation value is? Let's just say I would think maybe it's 0.32 and I hit enter. It's actually 0.52. So the correlation value here is 0.52. So we go next. Try it again. In this case, I would think this is a pretty strong correlation. Positive, going from left to right, it's going up. I would say this is 0.75, I'll guess. And the true R value was 0.72, so I was pretty close. Let's try one more. Again, it's positive. The dots are kind of scattered, so it doesn't look as strong as the last one. Let's say that's a 0.44 correlation. And it's actually 0.45, so I was very close again. So if you guys want to try out this website, it definitely gives you a good feel for how correlation works, and it's pretty fun at the same time, especially when you got nothing to do. So again, looking at this scatter plot here, and this is kind of describing all the specific points in a scatter plot. You got your dependent variable, your independent variable, you got your points, those are the blue points, okay? And then when you have your points, what we like to do when we have a scatter plot is we like to connect a line to it, what we call the line of best fit, or also known as the regression line. That's just another fancy way of saying the line of best fit. Okay. And all that line is we take the points and we try and connect a line through as many points as we can. Okay. And then don't forget about this word here, outlier. That's something that we learned, I think, 2 lessons ago. See how it lies outside the rest of the points. Okay. And there's actually a cool way that we can find, or there's a cool way on how to find the line of best fit or the regression line. And that way is through our calculator. So let's take a look at the first example. How to find the line of best fit. And again, this is known as linear regression. So here, it gives us a table of values, right? At the x value of 1, the y value is 1. At the x value of 2, the y value is 3. 3, 5, 4, 8, and 5, 7. Okay? So if you want to figure out how to find the line of best fit, the steps are here. The first step you got to do is hit stat edit. So everybody should take out their calculator now. First step, calculator, you want to go to stat. So calculator out. First thing I'm pressing is stat. And then you want to hit edit. Okay. we should be getting good with this now. Brings up this whole thing, L1, L2, L3. Notice how it gives us X and Y. So X is going to be our L1 and Y is going to be our L2. Okay, so we're going to want to put these into L1, put that into L2. Go ahead and do that now. And make sure they are in the same order that the table gives you. I can't just do 1, 8, 5, and 7, and then 3. They have to be in the same order that the table gives it to you, or else it does not work. So exactly as I see it, if you need to pause the video, go ahead. But from there, after you enter those into L1 and L2, you're going to want to hit Stat again. Then you're going to want to go over to Calc. And you look at the options. Which one do you see that you would think we would want for linear regression? Well, we're going to want linreg. And that is the fourth option down. This one right here. Hit Enter. And then go all the way down to Calculate. And then it gives us this cool looking thing. Y equals AX plus B. And that looks an awful lot like y equals mx plus b, doesn't it? Which means a linear line. And that's really all it is. It's just, I don't know why they use a instead of m, but it's the same exact thing. And it tells us that our a value is 1.7, and our b value is negative 0.3. So, to find the linear regression, all you gotta do is substitute it in to y equals ax plus b. So your answer should be y equals 1.7x minus 0.3. And also do not forget that 1.7, that is your slope. And that minus 0.3 is your y-intercept. But your final answer is this piece here. Okay. Y equals 1.7x minus 0.03. And if we want to try and give a line of best fit, we can. We would try to get it as close to these as possible. Never forget, every time that we sketch, we graph, we need to know what the equation of this line is. That is my line of best fit, my linear regression. Let's do one more example. Okay. Here, find the linear regression formula for the following points. So here it gives us the graph, but it does not give us the table of values, nor does it give us our line of best fit. So what I want you guys to do is fill in the table of values here. So first one should be 0, comma 3. The second one is 1, 6. Then we have 2, 4. Okay. So fill in your table of values. Check. Step 2. we got to put this whole thing into our calculator, into L1. Don't forget that our x is going to be L1, and our y is going to be L2. So go ahead and put that in the calculator. To erase all of the values in these tables, you have to go up to the list number. So this is L2. You got to hit clear, and then you have to hit enter, and it will erase everything in that list. So same thing for L1. Got to hit clear, enter, and then you can start fresh again. Make sure you have same number of numbers in each list. And then we hit stat calc. Go down to linreg and calculate. Okay, so this is our new linear regression, our new line of best fit. Our new A value, our new slope, is 0.82857. Let's just round that, 0.82857. And our B value is 3.76190. So, for our linear regression in this case, it is going to look something like y equals 0.83. Let's round to the nearest hundredth. X plus 3.76. And then again, if we want to put that on our graph, you got to use a straight edge. And then we try and connect it as best. And we try to connect it as best as we can, as closest to all the points as possible. Something like that. Label your line for completeness. And that is our linear regression from a scatter plot. And that will be the end of this video.